we are covering here Unix style command line, mostly probably focus on Linux systems nowadays. And this is because this is what is mostly used in HPC systems nowadays. So this is something that if you do some research and needs to access some HPC resources, probably you're going to need to use at some point. So the kind of command line that we are going to cover is called bash. There are different kinds of command line interfaces, different what we call shells. Generally are maybe 95% compatible between them, but there's always some little bit changes in the syntax. So at some points it may be that if you are using some command line and you move to a system that uses some other command line, you need to make changes to your code or scripts, but generally they are going to be quite similar. So hopefully by the end of this course, you will feel more comfortable and understand why it's important to have a command line interface and what kind of flexibility gives us compared with just a normal graphical interface. Get some familiar with some of the commands that we usually need to use often, like creating folders, moving files, editing files, and so. And just maybe a little bit of overview of some of the tools that we can use in the command line interface, like Nano or Vim to edit text files in the command line. I don't know if we have here some references as well. Working remotely, yeah, maybe in the section of working remotely, we'll see as well how to connect to a remote server or HPC resource and upload files there. We are going to just have a little bit of time to cover it, so it's going to be more just a showcase almost, but hopefully will help you to understand how it works. So let's start introducing the Linux command line, and something that many courses I've seen, sometimes they just skip. That is the concept in the Unix command line that everything is a file. So you will see that you are in this text interface like this one here. Here I'm just going to use the browser inside my Jupyter lab because it's easier for me to change between tabs than not having many windows open. But you have an interface like this where you are typing things and you see in the screen, and maybe you press then enter and you have some output. So all these things that you are seeing here that I'm typing as an input, so it's reading from the keyboard and then it prints something on the screen. Basically, in Unix command line systems, it's all managed as different files. So there's a file that is the input file that it reads from the keyboard, for example. There's a file that is the output file that it prints on the screen. Even there are kind of two different ways to print on the screen. One is using the normal output, that is the one that it used here. Or if I run something that produce some error, it will print, maybe it will show as well in the screen, but it will use a different file pointer that we will be able to use after to kind of separate one output from the other. And maybe this can seem a little bit confusing, but hopefully a bit later you will understand why it's important to highlight at this point that everything is a file. So very easy, an interface like this. As I said, we can type commands, a very simple one like echo. Basically echo, it just prints something on the screen. So echo hello, and it prints as an output hello. You will see that in the command line, usually you will have something like this. Here you have that this is my username. After you have here and then this is the name of my host machine. So this is the name of my laptop. Here you can have a bit of differences between different systems. So it can be this style and a percentage. Sometimes it's a hash. Sometimes it's a little arrow to the right. But basically, this just indicates that the system is ready to get a command as an input. So we can do things like checking what's my working directory, and I will expect that when I open my terminal for the first time, I will be in my home directory. So if I type pwd, that this stands for print working directory, I will get that currently I'm working in my user directory. So it's user slash and my user name. Important to remember that when we work in the command line, the commands are case sensitive. So if I come here and I try to type echo hello with capital letters with echo, oh, actually it's quite weird that it accepted it. Maybe it's something that is Mac have changed, but generally is case sensitive. Apologies for this. I haven't tried it actually because I assume that, of course, it will fail, but it seems that maybe some systems, they can have some a bit tolerance of this kind of changes, but generally I will expect that the comments to be case sensitive. If usually when you are in the terminal, this will change between different shells, but in the normal ones, if it's a bash shell or a ZSH, that is the Mac one, when you press the arrows up and down, you can see that I'm able to see the previous commands that I use. So this is quite handy if you need to repeat some command and you don't want to type it again. You can just press the arrows up and down and it will recover back the track of previous commands that you have input. If you type some command and you are stuck on it, for example, if I type echo, let me think, just for example, top, and I see that this is a command that prints the process in the system, like all the stuff that is going on, and I want to terminate this and I don't know actually how to do, and I press enter and things are just showing. One way to terminate commands is with Control C. So this will terminate the command that is running. And when you are done with a terminal, you can just type the command exit and this will close the terminal. In this case, you can see that it closed and it went back to my Jupyter main page, but don't worry about this because I'm just opening again a new terminal. And here we have a clean now new terminal to continue working. So here you have a bit of general syntax how things work. Just to mention that traditionally Unix systems have kind of help for the different commands, that is the man pages. So if you type man and a name of a command, it will show you some kind of documentation for the command. That if you press enter or you press space, you will scroll down in this page. And if you want to exit, you need to press the letter Q. So if I press Q, now I'm again, I press Q and it will just exit this command. Let's see different commands that we can use. First of all, to navigate our file system. I already mentioned before, you can check always what is your working directory just with pwd. And then when you know where you're working, you may want, for example, to create a new folder for your project. So I can do mkdir, make dir, and a name for a project. So for example, command line interface course. Now I'm still in my home folder. So if I want to go inside this folder, I need to type cd space and CLI underscore course. You saw that I type very fast the second part, CLI course. This is when you start typing something, for example, CLI, and I want to autocomplete the rest, if I can press the tab key and it will autocomplete, or if there are many different files or folders that match the same pattern, for example, I have this, I press tab and it shows that I have two different folders. One is called CLI course, another is just course. It will, when you press tab to autocomplete, it will show you the different options, and then you can type the beginning of the unique name and press tab to autocomplete. So I type cd CLI course and then go inside this folder. And if I want to look inside the folder, what is in there, I can type the command ls, is to list the files. And as expected, I just created an empty file, so there's nothing inside there yet. So how to create a file? One way to do it is use a text editor and just give a name to a new file. For example, we have the text editor called nano, and I could say that I want to create a first file called first.txt. So I can type this command nano first.txt, and this will open the editor nano. That is one of the editors that are generally available in command line systems, that have an interface that you can see that all this black area is where you type the text. And then you have in the bottom two lines with kind of reminder of the shortcuts that are available that you can do. So here I can type whatever I want. For example, hello, and I can say, and when I'm happy with the edits I did to the file, I need to use these options here on the bottom to save the file. So for example, here it says that if I want to exit, I can press Control and X. So I press Control X and it will say, oh, the buffer have been modified. So the file have been modified. Do you want to save the changes? So yes or no. I can press Y. And now it says that the file have been written. So the changes have been made in there. And it's asking actually, sorry, it's asking actually what is the file name. So it shows me the file name I define. If I want to change, I can make changes to the file name. I can put first one, first two, or so, but I will just keep the same. So I just need to press enter, and this will close the nano editor and save the file. If I want to look inside the file what it is, first of all, I can type ls to see, okay, now in the folder I have one file called first.txt. And if I want to look inside, I can use the command cat, for example, and you will see that inside that file, there are the lines of text that I typed. If I want to edit this file now to make some changes, for example, I can just simply say again, nano, and again the name of the file, and you can see that now it opened the file with the previous lines. So now I'm here, I can add some lines. And when I'm happy with it, again, I press Control X. Sorry, I pressed something wrong. Control X. Now it says again, do you want to save the changes? I press Y to say yes. It asks me, do you want to keep the same file name? I'm happy with it, so just press enter. Or maybe we can do something because we are going to need to create a few files. So I'm going to just remove this and I type second.txt and I press enter. And now if I type ls, you can see that now we have two files created, first and second. So if I look inside first, you see that is the file that I created before. But if I look in second, you see that is the file that I created before plus the line that I added, so it's a new one. Something a little bit more advanced that maybe is good to learn it early, that in the command line you have some kind of special characters that allow you a lot of flexibility in the commands that you run. For example, if I want to print, open, look inside all the files that end with txt, so all the text files, I can type something like this. So basically I'm saying that using the command cat for any pattern, any matching file that starts with something and ends with .txt. So if I press enter, This will open both files that I have created, first .txt and after here second.txt. We'll see later that this is very useful as well, needs to be used a bit with responsibility because it can create a few issues if you are not careful with it, but we are going to see this in a little bit. So what other kind of actions you generally want to use when you work with files? For example, you want to copy files, so you can say that I want to copy the file first. Oh, sorry, I didn't see that actually every time that I was typing first, I was typing it wrong. So something that we can do is rename files. And instead of renaming file, having a command called rename, we are going to use the command mv for move. So it's the same moving one file from one place to another, that changing the name. So if I want to move this file first that I type incorrectly to first, I can do something like this. So I want to move the file that I created to the new one named correctly. So I just need to type origin file, destination file. If I type ls now, you can see that both are correct, the names that I wanted. And if I have something like, for example, I can create a folder inside the folder that I'm working. For example, something that we many times do at work is creating a file just as a backup, for example. So now here I have two files and one folder, and I want to create or to move first the file first to inside this folder backup. I can type something like this. So move first.txt inside backup. You can put slash at the end or without, it will be the same in this case. If I type ls now to see inside, you will see that now the file first disappeared. But if I go inside the folder backup, type ls, you see that the file is there. So maybe now I say, oh, I wanted to move, but I wanted to create a copy. So just a reminder, now I am inside the folder backup. So I will use the command copy and say I want to copy this file first, and I want to copy in the parent folder. And to indicate that I want to go to the parent folder, we have this way to do it, that is two dots and a slash. This will take us back one level up in the folder hierarchy. So if I type this, I have ls, I still have the file here, but if I go back one level, so here I use the same syntax, cd, and I want to go one level up, so two dots and slash. If I type pwd, you can see that now I'm back in the CLI course folder, and I type ls, you see that now I have still the backup folder and then a copy of the first.txt file and still the second.txt file. If you want to see more options or more arguments about these files, instead of ls alone, you can type ls space minus la, so options that the command allows you to get more information. And here you will see that now it printed things in kind of a list with all different attributes for each one of the files. And we'll see a bit later what are they, but this is more related like to permissions of the file, who is the user, that to what user it belongs, to what group it belongs. Some extra attributes is this is the size of the file in bytes, and then the creation or last modification of the file. Good question, Roger. No, it's not. It doesn't depend on the file name. I could create a file, for example, first.txt copy as just first. And now if I look inside, you can see that I have twice this. I have first and first.txt. So these are two different files. Both contain exactly the same because it's just one copy of the other. The thing that it makes it the system distinguish is like a special attribute that it have, that when you use ls minus la, it will be shown here with a D at the beginning. So files will start with just a dash, and folders with a D. Uh, some of the terminals that you will use, they will highlight things in color. So sometimes you will be lucky and you will see that folders are shown in blue, for example, and then files just in white or yellow. And that will help you as well to distinguish what is a file or a folder. But if you don't have the coloring option, like in this case, using ls minus la, you can see the first character in each line. It will indicate if it's a dictionary, sorry, a directory, a folder, or just a normal file. There's some other options. In some cases, you can see that there's an S. This is more like the S is for special kind of files, but for normal use, I don't expect you to see that often. So generally, you will see these two options, or D, or just a dash. What other commands we can? It's important to know when working with files. Here you have in this page of the file system, you have at the bottom just a summary of different kinds of special characters that you can use. We have seen just this wildcard, this start, that it can replace any type of character. If you just want it to allow to be replacement of one single character, you can use the question mark. That will allow you to have, for example, file 1, 2, 3, 4, 5, 9, but not file 10, because it's going to be two characters, so it will not match that pattern. And some extra options that you can specify exactly what are the matching that you want. For example, with the square brackets, it says that you want here to be a 1, a 2, or a 3. So it will match patterns like file 1, file 2, file 3, but file 4 will not be a match. And other kinds of expressions, this will be interpreted as a sequence, but this is a bit more advanced, and don't expect you to use it so often. So let me try to follow the materials. What else we are missing? Lesson tail. Two other commands that we can use. We have syn cat to print the contents of a file. If the file is very, very long, if you print cat, it will show you a lot of data there. So let me try to create one. Let me see. I think if I get with top. Yeah, now I created a file that is very long. If I type ls minus la, you will see that this file compared with the others, the size of the file is much larger. If you type instead of ls minus la, h stands for kind of human readable. So it will show more in a just shorter version. So it says that this file is 1.4 megabytes. So this is quite long file. And if I use the command more instead of cat, or let me just use cat actually, cat.txt, you will see that it printed really a lot. I can scroll up the window and there's a lot of things that it printed there. So if you have files like that and you just want to see, for example, the header or the last lines of the file, you can use the command head. So head.txt, and it just will print, I think by default is the 10 first lines of the file. If you want to print any other number, for example, less or more, doesn't matter, you can use dash and then the number of lines. So in this case, I'm just saying I just want 5 top lines. So these are the 5 top lines of the file. Or if you, instead of wanting the top lines, you want just the lines on the bottom, you can say last instead of head last. So the last 5 lines, I'd say that are these ones. Probably here there may be some characters, but without it will show you. Let me print a few more. Apologies. I'm typing last and it's not last. Is tail. Last is another comment. Tail top. It will show the 10 last lines. These lines are quite long, so they are not truncated here in the terminal, but each one of these 3 lines corresponds to one line. So if I want to print just the 3 last lines, tail -3, and it will just get the 3 last lines that are actually, they are long, and this is why they are truncated in multiple lines, each one of them. Yeah, the comment that I was showing is last. It's about system logins, nothing related to what I was wanted to show. So yeah, doesn't matter. Ignore that. Useful things that we can do in the command line. For example, if we have an output, and sometimes I've seen this, that some specific programs, they have an output that corresponds to each one of the variables, and you want to count how many samples they have been collected, for example. We can use the command wc, and this stands for word count. If I type without any other information, just workc and the name of the file, it will return how many, I think it's how many lines here, how many words, and how many characters it have. If I want just the number of lines, for example, I can type wc -l, and this will return just me the number of lines that have the file, or maybe if I just want the number of words, I can use this one. So the word count -w, and just it will print just the number of words that it have. Something connected to what we saw before. If I want, for example, to get how many lines have each one of the files that I have in my folder, I can do something like this. So word count -l, special character, this star, and all the files that match this pattern, anything.txt. So now I will have as an output that the first .txt file have 6 lines, second .txt 8 lines, top.txt have 4,600, and the last line that says total is actually the total, the sum of all these values that have been returned by different files. Another command that it can be useful, I don't have any file prepared to run this, so I will just mention it, that you can use the command sort, so it will sort alphabetically, or if the line starts with numbers, you can use it numerically as well, starting with this -n. This is just to account that if you sort alphabetically and you have a 10 and the one line with starting with 100 and the other one starting with 0999. The fact of starting with 0, even the number is higher after, it will make that when you sort alphabetically, that will go first. If you type this -n, it will identify that is a value, so it will sort things in terms of the numerical value and not just the characters, the order of the characters. Another command that is quite useful is cut. So cut allows you to cut parts of the file based on columns, space, and a specific delimiter that you need to say. In this case, for example, we assume that we have a CSV file that is called data.csv. As a CSV file, we expect things to be separated by commas, by colons. And we are saying here what fields do we want. So basically we're saying we want field 1 and field 3 from this file. This is something that we can do with the file that we created before. For example, let me just remind what is the format. Maybe a little bit more. Okay, we have a lot of these lines that it seems that values are separated here with spaces, and we may want to cut parts of the file just based, say, oh, I want just the second column, or I want the third column and the fourth column, or whatever columns do we want. So I could do something like this, command cat -f to indicate that I want the file 3. I will just take 1 for now. I'm going to say that the delimiter is a space, and then the file name that I want to use, in this case, is top.txt. If I type enter, now it got a lot of blank spaces for two reasons. First, it tried to get all the output from the file. So I'm gonna do something that I will explain later, that is command more with a pipe. So basically now it just took some of the output. And if we go to the top of the file, this output basically corresponds what we saw there, mainly at least the first lines to parts of this. There's a problem with this output that we say that we want to separate by blank spaces, but things are not always separated by the same number of blank spaces. So we need to do some changes in this way to work if we want to use blank spaces. And we can check actually in the man pages. So we want to check for cat, man cat. And here you have the explanation of the command, and let's see if we can find how to manage different white spaces. So use white page, a separator, and consecutive spaces and tabs count as a single separator. So if we specify this -W option, should be able to handle white spaces. I don't know if it's with both options together or just with W. Let's try with just W. Oh, here it is. Yeah, with just W, it worked fine. It got the third column with the values that we wanted to recover of this case is CPU time that it used. Great. So I already said here that I'm using something that we haven't seen, that is a pipe, and there are redirections we call that we can use in the command line to kind of concatenate things and to commands and to save outputs, or even take inputs from one command to another as if it was typing in the command line. And this is a bit related to what I explained in the beginning, that the command line treats everything as a file. So if I want to save the output that goes to the normal standard output into a file, for example, I can say that I want to save the output of cat top in a file called cattop.txt. I indicated this with this arrow to the right, saying that I want to save the output from this command into a file. So now if I look into this file, cattop.txt, you see that here you have the output from the command. And this is kind of a useful thing for the command line, because it allows you first to be able to capture easily the outputs of different programs, but as well to concatenate as well different commands. For example, if I want to use this and after just run the command head, instead of the right arrow to the right, I just would put the vertical pipe, and I will say that I want to now get head from this command, just the first lines. And now I concatenated two outputs, not really saving it in a file, but kind of creating some kind of temporary file and redirecting the output of one command to as an input of the next one. So basically here I'm just getting the head of what is the output of this command. And of course, this is just 2 lines, but here I could concatenate many different commands. For example, I can say, now I want here word count -L that we saw before. And basically it will say that this command, after I go to head, so head just prints the 10 first lines by default. And after I want to count how many lines have been printed, so basically return that this is 10. David is asking, what could you type if you want to cut specific rows instead of columns? One simple way to do that, it's using the commands head and tail. So if you know that you want to get just, for example, if you start with simple case, you want to just get the first 1,000 lines of one file, you could just do this. If you want to get just the 1,000 lines, you could do this. The last ones. If you want to do intermediate, what you could do is concatenate both commands. So I want to get first the if you want to get something like from 1,000 to 2,000 lines, I could say, first of all, head, I get 2,000, and after I concatenate tail, and I get 1,000. So I cut first the first part, the first 2,000, and after I just get the 1,000 on the tail of the last part of this. For example, I can run this something like this, and let me just put smaller numbers for the screen. So basically with this, I cut the lines from the 10th to the 20th. Yeah, we just put here in the chat. Great. We have seen how to edit files with Nano. There's another editor, Beam. Beam is slightly ramps a bit more up the learning curve. It's a little bit more difficult to get used to it. I recommend at this early stages to use Nano. Just be aware that if you want to use Beam and you want to learn a bit, it's also very useful command. Other things that you may want to do when you work with files is find a file. So you remember that you created a file, you cannot find in the folder, so you want to find where you put it. So we have this command find, very easy to use. So find, find, you need to say from where you start. So I can put dot slash, see this is the current directory I'm working. I could put like 2 dots slash, the parent directory, for example. Doesn't matter in this case, just to make it easier, just I will put like this. Then I can say I want to search by name and I want to find the file that matches the name first.txt. If I type enter, now you will see that there are 2 matches actually. From this folder, I have first.txt, but also I had a copy that I created inside the backup folder that have exactly the same name. If you want to find, for example, all the txt files that you have created in your folder, you can make use of the special character star. And you only need to remember that in this case, you need to put this, apologies because I have keyboard language. Here it is. You just need to remember that you need to put this into quotations to work. This is something that is mostly for the command find, that other commands usually they work without, but in this case, you need to put the quotations if you want to use special character. And here the output is all the txt files that found in the working directory I am. And yeah, you can see that are the ones that we have been working previously. Another thing that you may want to do is, instead of finding a file by the file name, is finding a file that inside the contents, there's some matching pattern. For example, I may want to find all the files where I type my name. So grep, Pau, and any file that I can find. And you can see that it gives an error saying that backup is a directory, and so it will not, not error, a warning. The backup is a directory, so it will not look into it. That's fine. And the second thing that it says that inside second.txt, there's a matching, and it's in this line that says my name is Pau. If I change this and say, I want to find the files where I type hello, here you will find again, it gives a warning, cannot look into the directory by default, but there's a matching pattern inside these 3 files that we created before. And if I want to make it be able to explore inside directories, of course, in the directory per se, there's not going to be a matching. The directory is just a folder. But if I want to explore the files that are inside each one of the folders as well, I can put the option -R. I don't remember if it has to be capital letters or not, but in this case, it seems that it works fine like this. And if I say grep -R, grep -R, it's like saying do it recursively. So inside all the subfolders that are in the current folder. And it will find that as well inside backup/first.txt, there was a matching of the word hello in a line that just says hello. So just be mindful that, of course, finding files just, for example, in this case by name is relatively fast. If you do something like this and you are looking in your hard drive, it can take a while because it will try to read all the files and look inside if there's a matching. Another part that is important that we saw when we were typing ls-l is about permissions. Sometimes if you type something like this, grep -R, and I will say something like this, let's see, no. I'm not lucky with it. I wanted to get some error message of things that I cannot do. Oh, here you have. So basically here I got a message saying, oh, I was trying to read these files to see if there's a matching of the word hello, but says permission denied. And this is because I don't have permissions. These are like system files. So by default are blocked for not having issues. So just as an administrator, I can edit them or actually even read them. So we already saw before that when we type ls-l, we have these characters at the beginning, and as I said, these define the permissions. So we need to understand this as a three different blocks. This is permissions for the user to who the file belongs to. This is permissions for the group, and this is permissions for all other users. Each one of these characters is a different permission. So the first one R is permissions of reading. So the user can read the file. The user can write the file. And if it's a program or a script file that executes some code, you need to have as well permissions defined for execution. So if you have just read and write, you will not be able to execute a file. Or if it's a folder as well, the permissions of execution, like in this case, it means that you have the right to open the folder. This repeats 2 other times for, as I said, for the group where this belongs, and any other users. So if you have something like this, you see that as a owner of the file, I have permissions to read and write the file. It's a TXT file almost, a YAML file. It's just a format that is text inside. And all other users, they have permissions, for example, to read the file, but they cannot make changes. What happens if we want to change this? For example, I say, oh, this is a file that's very private and I don't want anybody else to be able to read from it. We have the command chmod. I can say group it's G minus read minus R, and then the name of the file that, for example, I'm going to say first.txt. If I type ls minus la, now you see that the permissions that I had before that were read alone, now they have been removed, and the permissions is just for the group is nothing. If I want to say for all users, I can type minus A, and this will remove the permissions for all the users, for all the groups, sorry. And if it's for owner, I can say owner. And in this case, because I remove for all, I can say I can give back. So instead of minus, I can put plus owner plus R, and this will give back the permissions for back to the owner for reading. Sorry, I always confuse the letters. O, it stands for others. And if it's owner, it's, I think it's without any character. Yeah. If you type without any character, it's going to be for the owner. If you type with O, so O minus R, for example, that now we have permissions. Now I remove permissions for other users. There's another way to do changes on the permissions that is like using these 3 blocks as a binary character. So in binary, 7 is 111. So we are giving permissions to all these values. And if we want to put just all the permissions and then for group and other nothing, I can put 00. So this will translate to 111.000.000. So in this case, we change the permissions to read, write, execute for the owner, no permissions for all other users. I could have put something like this, 777, so complete permissions for everybody. Here you can see. Or if you want to put something more neutral, for example, 755, that this should be 100. And here is what, oh, sorry, 101. So if I want 100, it's going to be 444. ls minus LA, and here you have that the permissions are back to just read for others and group. Great. I know that this part of permissions can be a bit confusing. It's something that you need to get used. And actually, when you are in HPC systems nowadays, usually this layer of permissions of the Unix system is not the only one in place. So you have in top permissions that can be assigned by Active Directory that can make things a bit more confusing, and you cannot see directly in the system. So be a bit patient when you have to work and deal with permissions, and always, if you have issues, contact HPC, because they will be able to help you with that. We have already seen redirections, at least the normal arrow to the right and the pipe that is in the bottom. Other permissions that redirections that we can do, because now if I redirect something, for example, cat first.txt to second, and now I look inside second, you can see that the extra lines that I added in the second file, they have been removed. So I overwrite second with what was the output of cat first. If you, instead of deleting the content and saving in that file, you want to append to the second file, you can use these 2 arrows. And when I look inside second now, you will see that it concatenated what it was previously in the file, plus the new output of the command that I type. And I can do this again, and you will see that it kind of accumulates the output one after the other as many times as I repeat the command. I was saying in the beginning that we have kind of 2 outputs, the standard output where the normal outputs of a program are expected, but if there's some error, they go for the standard error output. If you want to capture that in a file, instead of putting this arrow to the right, you need to put number 2, because this is the identifier of that output file, the standard error, and then the arrow to the right as well. And if you want to capture everything, so the standard output and the standard error in the same file, you can use this. You can put an ampersand and after the arrow, and it will capture everything in the same file. I'm going to skip this section. Just be mindful that apart from working directly with the terminal, if you have some files that you want to, some set of commands that you want to save for later use many times, you can create what they are called shell scripts. So basically, the shell script can have a set of commands inside that I can, for example, create a file called script.sh. sh just a convention, what to use in the shell scripts. I put the content, I just press Ctrl X to save, I type yes, the file is name. So to execute a script, usually you need to do with dot dash and then the name of the script, like this. But if I try, it says that permission denied, because as I was mentioning before, you need to have execution permissions to execute a file, a script file. So I need to run first change mode plus X, give permissions to the user, myself, to the file that I want to execute, and now I can execute the file or the script that I wanted. In this case, it was trying to work with some files and there's no matching files, but doesn't matter. It executes the script despite the output not being very useful. Great. I wanted to just cover this section briefly. If you need to log in to a remote computer, if you have not done it yet, I mean, first of all, you will have to go to the HPC page and request access. I think that they have been kind of centralized in one single resource. So to request access, you go to some kind of form and you say that you want access to Blue Crystal or Blue Pebble. Once you have that, you will have to log into the machine, different options. You can use in Windows PuTTY is quite useful, or you can just use the command line and use SSH, that is as well available nowadays. So you can do something like this, SSH, you type the name of your username at, and then the URL of the computer that you want to log in this case, Blue Crystal 4. And you can see that my computer is hanging it here trying to connect, but I don't have the VPN on, so it will not connect. So just be mindful that when you connect, you need to have be inside the university network or have the VPN on. If you want to copy files to a remote computer, we saw before that we can copy files in your computer using cp command. If you want to copy files, you can use the command scp. So this derived but this tool SSH to establish a secure connection. Basically, you say secure copy. In this case, you have an example of how to copy a local file to a remote computer. That basically it follows more or less the same syntax that when you connect with SSH, that you have to put, for example, for the remote host, your username at the host address, the direction of the server. In this case, you need to put 2 dots and then the path where you want to copy things. You can copy from your local machine to the remote server, or you can do the other way around. You can say copy, connect to the remote server, get this file, and then copy it in my local folder like this. Something that we have not seen, but when you copy files, if I try to copy, for example, copy backup as backup 2, it says backup is a directory, copy is not allowed. So this is because I need to put this extra argument, say -r. It was the same that we use in other commands, like to say recursive. And so if I do this now, I created a copy of the folder, and the same apply when you use SCP. So if I want to copy a folder, if I use the -r argument, it will allow me to copy folders as well to the remote server. You have here some exercises are more focused on bioinformatics, but basically they play with head and tail commands and grep and all the things that we have covered. So if you are a bit adventurous and you want to give it a go, I think this is a good way to practice the use of the command line. Otherwise, hope this have been, quite fast, but a useful overview.